So, having explained all that, who can tell me what this is called? A hand plane. Excellent. That's a hand plane. Who can tell me what this is called? Chisel. Very good. Okay, it's a chisel. And who can tell me what this is called? Square. It's a square. So, everything that we use has a name. And if we're going to make this part of our trade, then we need to know the names of the things that we're going to be using every day. Now, you're going to be using all of these machines. And we might say to you at some stage, oh, I'd like you to go over and unlock the locking device on the docking saw and raise the saw up so that it's 5 millimetres above the table. You need to know what's the locking device. So what we're doing today is we're going to go through the parts of this machine. And we'll be doing that over the next few lessons, parts of this machine, and we'll go and look at the parts of the surface planer and the parts of the panel saw, so that at the end, we should be able to talk in a language that is common to what people would use in the industry. Okay? If you go out to work experience and the boss says, I want you to go over and set the stop on the fence of the docking saw to a certain size, you're going to know exactly what he's saying. So it's about learning the terminology of this particular machine. Okay, I'll just put these away. Probably the most important thing that you need to know first up is we have on every machine our safety operating procedures. Please make yourselves aware of what it says on those things. It'll be basically what we say as far as the lessons when we talk about operating the machine. But on every machine, if you're not sure, first thing to do is come and ask Mr. Granson himself. But it's certainly advisable to really make yourself aware of what's on that sheet. So that's our safety operating procedures, shortened to SOP. The next thing is this switch at the back, all right, between the two pipes. That's our isolation switch. Now the isolation switch is vital when we go to set the machine up or to do alterations that involves us getting close to the blade. The last thing that we want to have happen when we've got our fingers near the blade is for that saw to start. So by isolating the machine, we're turning the power off totally to this machine. All the other machines will work, but this one here will be isolated. So it's our isolation switch. The next thing we want to look at is our emergency stop. Now the emergency stop on any machine is just that. It's an emergency stop. We have our stop-start buttons, which we use for the actual starting and stopping. Some people get in the habit of just flicking this button here. It may not affect this type of machine too much, but when we have different types of switches, like our star delta switches, which we'll go into later, if we hit the emergency stop there and then we release it, sometimes that machine can turn straight back on again. So it's important that we only use the emergency stop for emergencies. Now it's placed in a position where if we're working bang, we can just hit that straight away. Okay? It will stop the machine. Our next piece, the next part of the machine is the actual start and stop buttons. Now on this machine here, we've got a black start button and we've got a red stop button. On all machines you'll find that you're either going to have a green or a black start button. Most of the times it'll be green. And you're going to find also that this start button is going to be recessed. What that means is that the surface of the button is below the surface of the housing. Unlike the red button, which is protruding. I can accidentally knock that. The last thing I want to do is to be able to accidentally knock the start button. So they recess that, and the stop button they have proud or protruding so that I can easily get to that and stop the machine. So, start, stop. Okay. Our next part of the machine we're going to look at is the guarding. I'll answer any questions very, very shortly if anyone's got any questions. Now, guarding on machinery is not governed by me, or it's not governed by Mr. Grant, it's not governed by the school, it's governed by the government. It's like laws regarding driving. There are certain things that you must do, otherwise you can get fined. If you don't do things right in the workshop, you can get fined as a worker. Okay? So, the guarding requirements are set down by the government. And what it says, I'm just going to isolate the machine. And once I've isolated it, I just test it. Yeah, that's fine. So the machine's got to be guarded in various places. First of all, it's got to be guarded on top of the saw blade. So there's no way in the world I can come in contact with the top of the blade. It's called a hood guard, or the top guard. And that there covers all of the saw, including the spindle. Now this machine also has guards on the bottom, which as we bring the saw out, is going to stop the machine from getting close to our hands. So we have a hood guard and we have an adjustable side guard. We've also got a front guard, so that when we're putting this or setting the machine up, we can adjust it. We've got this locking lever here, so I can be going to cut a piece of timber. The first thing I should do is lower this guard so I can't get my finger underneath it. That's going to well and truly protect your hands when you're operating the machine. So we have the hood guard, top guard, we'd like to call it, okay? We've got the adjustable side guard, and we've got the front guard, which is adjustable also. The machine should also be guarded at the back of the saw, and that's where that adjustable guard actually plays two roles. It protects it behind the fence, and it protects it in front of the fence. Alright, our next part is what's called the radial arm. Now, this is a radial arm docking saw, and this is our radial arm. The saw blade, or the motor, travels along that arm. There are bearings up under here, okay, and that will locate back in there, so it slides backwards and forwards. So our radial arm. Now the saw itself can be adjusted up or down. It needs to be adjusted up and down so that we can take the saw blade out. It needs to be adjusted up and down so we can do things like a rebate. We're talking in our setting out before about doing a rebate on the ends. We can do a rebate on the ends in this machine by raising the saw so it's not cutting into the table and having it set to a certain height. So our locking lever for adjusting the height of the saw is back on this side of the machine at the back. Now, I don't know if we can just pop around here, Mr. Grants, and just show where our locking lever is. It's down here. And the adjustment for raising or lowering the saw is with this hand wheel here. So we simply unlock the locking device and we wind the handle and the saw will go up or down. Okay. Next part we want to look at is the table. The table. The table is a flat bed which timber's placed on. Now, you're going to note that a table is common on docking saws, on surface planers, on panel planers, on rip saws. They all have something called a table. And that's that flat bed that the timber sits. The special part about this table is that it's a certain size. Now, I can only draw this saw out to there. And if I put the saw back in again, I can see that the saw cut finishes about 150 millimetres from the end of the table. Why would that be? Why would we want to make sure that the saw cut finishes in front of the table? Sorry? Absolutely perfect. Okay, a great answer. If the table was brought back a lot shorter and the saw blade protruded past the end of the table, then that would bring our clothing or our legs or parts of our body in jeopardy of being in contact with the saw. So once again, the government says when you put a table on one of these machines, the front of the saw cannot protrude past the table when the saw is pulled all the way out. Okay, so this is our table. We have other tables as well. There's little roller tables, and this here is where the timber simply just rolls along. And on this side here, we have the table. We've got the fence. Fence is the vertical part that runs against the table, and the timber is pushed up against. Now you must make sure that when you're cutting, that the timber is firmly up against the fence. Who's heard of something called kickback? What's kickback? It bounces back. It probably does more than bounce back. Okay? These saws here are made to run at approximately, or in excess of 3,000 metres a minute. So in 1 minute, if I let that saw blade loose, that saw is going to go 3 kilometres. So in 1 hour, if I kept it going, how far is it going to go? What's 60 times 3? 180. Well done. Okay, 180 kilometres. So around 180 kilometres an hour, it says for 180 kilometres an hour. If that saw blade catches the timber and the timber is not secure, that timber is going to come back faster than you will be able to react to. So if I have the timber in front of the fence and that saw blade hits it, then it's going to absolutely shatter everything. So you must make sure that you use the fence to put the timber up against. On this side here, Mr. Grant's like to wander on over. The fence has got measurements. Alright, why would we have measurements on the fence? So it makes it easier to set up to cut things to a certain length. Along with the measurements on the fence, we've got what we call the stop. And this stop here is adjustable and it's locking by means of this locking device. And I can set it to the length that I require. How accurate is this? How accurate do you think the measurements would be? Not very? Who says not very? Yeah, I agree. Okay. I wouldn't say that it's going to be very accurate. It might be, but then again, it may be not. What's our tolerance we're working to when we're making jobs? How close have we got to be to a measurement? If I want something cut at 500 millimetre, what's the tolerance? Plus or minus 0.25 millimetre. It's a quarter of a mil, which is very, very thin. Okay, that's the tolerance you've got to work to. So when we're setting this up, I would say we would use this measurement as a rough guide, but we would always check our measurements to make sure they're exactly spot on and make adjustments accordingly. All right, let's start pulling this machine apart. We might just stop it there a sec, Mr. Grant.